Hello guys and welcome back to this amazing channel. My name is Abhishek. Yeah, I am a brother of Abhinav and today I will discuss the solutions of this particular contest, which is Starters 131. Abhinav is not free today, so I will discuss all the solutions. My name is Abhishek, right? Cool. So today we'll discuss about the problems of this contest Starters 131, right? We will discuss the first six problems of this particular contest, right? Which is remaining neighborhoods till T-Perm, right? I can see the problems of today's contest was a little bit good. They were not much difficult, but yeah, they were of good level. They were really of good level, right? Especially last two problems were of good level, right? Cool. So let's discuss all the problems one by one. The first problem is very easy. As you can see, the problem simply says that you have to find remaining neighbors. So they are saying that there are 100 neighbors of Seth and he has already visited the n neighbors, right? So how many neighbors are remaining? So like as we know, nothing. There is no meaning of this problem. Simply you have to take input of n and then you have to print 100 minus n, right? So that is what the problem says. You have visited n cities. How many cities are left? 100 minus n cities are left. Simple, nothing else, right? That's the basic problem. Next comes gotta catch them all. Gotta catch them all. So this problem basically says that there are this n different Pokemons, right? And they are saying that ith Pokemon has a catching difficulty of AI. Okay, basically you need AI uh, Paco ball. Basically, some AI is a difficulty, right? Now, what they are saying is you have two types of Paco balls. One is a normal Paco ball. So, in normal Paco ball, if there's a AI difficulty of a uh, Pokemon, you have to actually use AI Paco balls also. So, exactly AI normal Paco balls are required to catch Pokemon with difficulty of AI, right? And each normal Paco ball is cost for X coins, right? And there's a master Paco ball also, which cost for Y coins, but you have to use only one Paco master Paco ball to catch any of the Pokemon, right? Now, guys, see, obviously you have two options. Let's say I'm saying you that. Let's say you want 5 packets of Maggie. You want 5 packets of Maggie, right? I'm saying one packet of Maggie costs 10 rupees, but if you will take a pack of five, it will be a 45 rupees. What you will choose? You will choose a pack of five because it is better. This will cost you 50 rupees for 5 Maggie, but this is for 45 rupees. It is better. But if I will say you, okay, one packet cost 10 rupees and pack of five, let's say, cost 70 rupees, then you will say, I'm not fool. You will take 5 packets of 10 each, right? Same here. You have two options. So for every Pokemon who has AI difficulty, you have two options. Either simply take one master Paco Ball for Y coins, or either takes AI Paco Balls like X Paco balls for AI Paco balls for X coins. So you have two options. Either simply invest Y coins and take a single master Paco ball. Either take AI Paco balls of X coins. So basically, your final decision will depend on the value of AI. Okay, and that is what you will do. So what I basically did here is, if you will see this code of mine, I've first taken the value of n, x and y, then I've taken the input of this ai means the array. Okay, now for each element of array I'm saying, see, if x into ai is smaller than y, I have to take minimum of both na. So if x into ai is smaller, I will make my cost is equal to x into ai, else I will make my cost equal to sum. If you want it more easy, simple, the answer will be, my sum will be the addition of minimum of y comma x into ai. That's it. So for every Pokemon, the cost that you will invest will be either y, either one master Pokeball you will use, or you can maybe use ai Pokeballs of cost x. Whichever is minimum, you can take that. Okay. So that is what the problem says here, right? Amazing. This was the next problem, which is gotta catch them all. If you still have any doubt in any of the problems, do ask that to me in the comment section, okay? Or you can also join our Telegram channel to ask your doubts, right? Amazing. Next comes dice deception. Okay, I'm very weak in English here. Dice deception. Okay, this is also again a very good problem. See here, what actually this problem says that Alice and Bob, again Alice and Bob are playing a game, a board game, where they have to basically roll a dice. That simple dice of six faces, right? That's the dices. It contains numbers from 1 to 6. Now what happens is that Alice actually played the game, and it has a sequence of values that he got after playing the game, right? Now what he can do? Bob was not paying the attention, so actually Alice can cheat. Means Alice can change values of the dice, but it cannot like change any value. He can actually only make dice opposite of it, right? So if you will see how a dice looks like, I will try to make it. I also have a very good art. So, and I hope I'm explaining as good as Abhinav. Okay. Uh, so yeah, this is a dice. Okay. Now each face of a dice contains a number. Let's say this is 1, then this is 2, this is 6, this is 5. Okay, so 2 is in front of 5, 1 is in front of 3, and this is 3, and this is 4. Okay, this is how a dice look like. I've tried to make it. Okay, so if you will see, 1 is in the opposite of 6, 2 is in the opposite of 5, and 3 is in the opposite of 4. That is what is given here also, right? So what you can do is basically, for example, that the array that is given to you, this array actually contains the values that allies got using their chance. Let's say allies got these values: 2, 5, 1, 6, 1, 1, 3, 4, 2, 6. I will make it large. Okay, make it large like this. Okay, like this. Okay, up they go. See what allies can do. Allies can actually flip the dices into its opposite value. Means he can make 2 to 5, 5 to 2, 6 to 1, 4 to 3, and any of that. He can flip the dices. But why he will try to flip it, right? He will try to flip the dice to maximize the score. Basically, he wants to make the score maximize, and also he can only flip k dices at most k times. Not exactly k. See, at most k means maybe he will not make any flip. At most k times he has to make. Okay, because in some cases there is no flip needed. For example, if the array is 666, in this case no flip is needed. Already Alice has maximum numbers, right? But for example, the case where we have, let's say here our k is 4, that means we can make 4 flips. So which flip you will try to make first? Will you try to make 2 to 5? See, if you will make 2 to 5, you will increase with 3 only. You will get the increment of 3 only. But if you will make increment from 1 to 6, you will have an increment of 5. So first you will try to increment all the ones, then you will try to increment all the twos because they have an increment of 3. At the last you will try to increment 3 to 4. Else you cannot try any one of that. You will not make 4 to 3. No, it will decrease the sum. You will not make 4 to 2, 5 to 2. You will not make 6 to 1. You will always try to make the number which are 1, 2 or 3 to 6, 5 or 4. That is what you can do. Okay, and how many times? At most k times you can do. At most k times you can actually do this thing. Okay, amazing, amazing. So if you will see here, what I'm doing is, first of all, I will sort this array. So after sorting, it became 1, 1, 1. Then there are 2 2s and 3 3s are there. Then 4 is there. Then 5 is there. And then 2 6 are there. I hope this is okay. We have to make this 4 times only. So what I will do, for the first 4 numbers, I will flip it. If they are less than equal to 3. For more than 3, we will not do that. I will make it 6. I will make it 6. I will make it 6. I will make it 5. Okay. 4 are done. Let's say the value of k is 7. I can do 7 flips. So I can come till here actually. 7 are done. Let's say if it is 9. See, if k is 9, but even still we will not make 9 swaps. Why? Because after this, if you will make swap, your value will get decreased, and you don't want your value to get decreased. So you will only do swaps until you have k swaps remaining, and the value is less than equal to 3. For more than 3 value, you will not make any flip, right? So if you will see what I did here is, what I actually did here is, Hanji. So if you will see what I did, first of all, I got this A, right? Now what I did, I sorted the array. As I told you, we'll sort the array. Now, for a value which is less than equal to 3, and this j is counting number of operations we did till now. So if the value is less than equal to 3 and the operations that we are doing is less than k, we cannot do more than k operation. If these both the conditions are fulfilled, in that case we will not add ai, we will add 7 minus ai, because 7 minus ai is the number opposite of it. For example, 1 ka opposite kya hai? 6. 7 minus 1. For 2 it's 5, for 3 it's 4, right? That we will add there, and we will increase j plus plus, means we are done one operation. Else, if either ai is greater than, or if we have done all the number of operations, we will simply add that same number, we will not make any flip, right? That's the thing, guys. So that is how we are solving this particular problem, which is dice deception, right? Cool. Moving forward, we have next, which is K-Closeness. So let's discuss this problem, K-Closeness. You are given an array A of length n and an integer k. You can perform the following operation. So basically, this is actually a very good problem. This problem says that you are having an array A which basically has some numbers, okay? What you can do, you can actually choose an index of that array and you can increase that index by k, by value k. By doing this, you have to find the minimum possible value of max a minus min a that you can get. Up, let me give you an example of it. For example, the array that is given to you is like this. Let's say it's 6, 1, 8, 11, 20, 5, 9, 2. Okay. And now let's say that value of k is 4, right? See, now you can add these numbers with a value 4 such that the difference between them is minimum possible. Difference between the maximum and minimum element is minimum possible. That is what you have to find, right? Ab dekho what you can actually do here. Okay, see, up first of all, see guys, what you can do, you can first of all make all these elements up to a particular level. Dekho, for example, this is a 6, this is 1, this is 8, this is 11, this is 25, 9, 2. See guys, if you will see, you can add any multiple of k to these numbers, any multiple of k to this number, but their remainder with k will always remain same. If you will find for every number, if you will find its remainder with k, means with remainder with 4, let's see what will be the value we will get. If you will find remainder of 6 with 4, value will be 2. 1 with 4, it will be 1. 8, it will be 0. I am finding remainder with k, which is 4. 3, 0, 1, 1, and 2. If you will see, these are the values that we got after taking remainder of all these number with k. See why I did this. I did this because you can make all these numbers at the same level with k. How? Let's see. You can make this equal to 102. You can make this 101. You can make this 108, 103, 100, 101, 101, 102. If I will ask you, can you make all these number equal to this? Yes, you can actually make. Why? Just add some force. It can become 102. This can become 101. This can become 100 actually. This can become 103. Okay. This can become 100. This can become 101, 101, 102. So these all the numbers we can add 4s and we can make them at a single level, in the level of 100, but their remainders will be there only. Here remainder will be still 2, is still 1, so remainder will never change. We can make them at a level, but their remainder will never change. Okay. Now the only concern here comes is if you will see the current difference. If you will see the current difference. So first of all, if you will see here, what I did is, first of all, whenever I am taking the number, I am finding its mod with k. After finding its mod with k, I will actually sort it. After sorting, it becomes 0, 0, 1, 1, 1, 2, 2, and 3. Okay. Now let's find a difference. So if you will see, current difference is 3 here. Current difference between the maximum and minimum number is 3. We have to reduce this difference, and actually we can reduce it. How we can reduce it? Let's discuss. See guys, see how we can reduce it. What we will do, we will actually, for every, see how we can actually reduce this. See, this is 0 and 0, but we can actually make it 4 and 4 after adding 4. See, assume them not as 0, assume them as 100 only. Okay, I've taken here as 0 because that 100 doesn't matter, right? Now what I can do, I can make it to 4 and I can make them also equal to 5. And when I made it to 4 and 5, now if you will find a difference, minimum value is 2, maximum value is 5, still difference is still difference is 3 only. But we can actually reduce the difference. How? इसको भी कर लेते हैं, make it 6. Okay, difference अभी भी 3 ये क्या? Okay, difference will so here the difference will not matter because all the values from 0 to 3 are present. Let's say these values are not present. For example, ये value present ना होती, ठीक है? Okay, let's me explain you with the help of the logic only. जो यहाँ पे logic use हुआ है, it is then better for you. अब see guys, what we will do, we will first of all find difference of two adjacent numbers. See, difference of these two adjacent numbers are just 0. Okay, now we will see if you will add that 4 in any one of these two numbers, what will be the difference? So difference will be that k will be added. So abhi difference kya hai? 0. 0 minus 0 is 0. But if I will add a 4 here, difference will become 4. Okay, difference will become 4. Now the thing is, if after adding that 4, if adding that 4 really, makes your difference less than the given difference, then it is better to add it. So if you will see now, after adding it 4 here, the difference is even got increased. It is not decreased. And one more thing, initial difference was 3 here. Okay, right. So if you will see, if I will add here 4, the difference between these two is actually increasing, not decreasing. Means will not add. Okay, cool. Move forward. If you will see here also you will find a difference is 1. And if you will add 4, difference will even increase. Means we cannot do. If you will check here. So by the way, I have taken a wrong example. In this example, difference will actually not change for any of the value. Let me tell you a value where the difference will actually change. For example, agar ye values not present hoti, if this all is not present, okay. Now if you will see the current difference, current array is 0, 0, 3. If you will see the current difference between maximum and minimum, it is 3. But we can actually reduce it. How? See, if you will see for first two value, difference will not reduce. But if you will see, if you will do the same thing, with what? Difference of first two numbers and add k there. Okay. इन दोनों का difference क्या है? 0. Right. The difference of these both the numbers will be 0. And if you will add k there, if that final difference is less than the initial difference. Initial difference was 3. But if you will actually add k there, अगर मैं यहाँ पे एक add k कर दूं, then you will see that what difference became 1. Means we can make difference of these elements 1. Right? देखो यहाँ पे आप नहीं करोगे, यहाँ पे difference will be still 3 only. But if you will add a 4 here, so difference between this 4 and 3 will be 1 only. That means we can get a minimum difference of 1. How? After adding 4 to both of these 0 and 0. You can get a difference of 1, right? So that will be the logic. It is a very simplified code that you've written, but if you will have a dry run, you will understand this code, how it is actually happening. So basically, whenever this gap comes na, जब देखो जब 1 or 2 था, then none of this case happened, because all from 0 to 3 were there. We cannot make difference more than 3, but we can do that when there is a gap. यहाँ पर you can make both 4 to 0. Okay, that's so actually we don't have to change the array. हम array नहीं change कर रहे हैं, we just find a difference. You can see we are not changing array element anywhere. We are just getting what can be a minimum difference, right? That's the only thing. That is what we are checking actually, right? ठीक है, cool. So let's move to the next problem, which is encrypt value. If you have still any doubt, guys, you can like still ask that to me in the comment section, or you can ask, you can join a Telegram channel to ask your doubts. Okay. Next, consider encrypt values. This is again, guys, like a easy question, even easier than the previous one. I'm not sure why it's the next problem. The problem says that you have an array of elements A. Okay. Now what you can do, you have initially a element S, which is 0. So initially S is 0, right? Now what you can do, for each element of this array, you can either add element AI or either multiply element AI to this S. That's the basic thing. For example, if the array is, let's say, 5, 1, 2, 8, 7, 6 and so on, मान लेते हैं ये हमारी array है. इसमें मैंने आई गेस सॉर्टिंग की है, बट हाँ, आई हैव डन सॉर्टिंग हियर. आई विल टेल यू व्हाई सॉर्टिंग आई हैव डन. ओके, अब ठीक है. लेट्स टेक array differently. Let's say 5, 1, 1, 2, 3, 4. ठीक है. अब see guys, the thing is, initially S is 0. Okay. So the first element that we will take should always be added in this S. That we cannot multiply, because we want the final value greater, maximum value final. Okay. So the first element that we will do with this S, we will always add that element. We will not multiply it, because multiplying with 0 will result in 0 only. So we will always add that elements, right? अब देखो बात क्या आती है. The problem comes is, if you will actually add this 5, S will become 5. But this 5 will make more impact if it is got multiplied. So if you will see, अगर आप 1 का multiply करो किसी number से, let's say there is a number x. If you will multiply 1 with any number x, it remains x. But if you will add a number with 1, the number got increased. Means whenever 1 will come, or even when 0 will come, because if you will multiply a number with 0, it will become 0. But if you will add 0, it will remain x. Means whenever the number is 0 or 1, in that case we will always add the number, and in any other case we will multiply the number. Are you getting? That's the basic logic of this particular problem. If either S or either answer, any one of that is either 0 or either 1, we will add, else we will multiply. That's the basic agenda. Okay. Also, see, because we have to add ones, so 1 should be initially present. So what we will actually do is, we will first of all sort the array. After sorting, it became like this. Now, because there is a 1, I will add it. Again 1, I will add it. Now became 2, 3, 4, 5. I will simply multiply. And that's the actual solution, how we will solve this problem. Right? So if you will see here, what I did is, I'm simply first of all taking an array. I'm sorting it. Initially, my answer is the first element of my array, whatever it is, because we will always add the first element. We can never multiply the first element with 0. Whatever is the first element, doesn't care, but we will always add it. We will never multiply it. That's the very first thing about the first element, right? We will never multiply, we will add it. So our answer will be initially AI. Whatever is the first element, we will add it. Okay. Now what will happen is, for the other elements from index number 1 to n, I'm first seeing if the element is less than equal to 1, means if it is 0 or if it is 1, or even if the current answer, if the current value of S is 0, 1, in both the cases you will add the element, then you will not multiply, because multiply will not make any increment, it will even decrease it. Else, in the else case you will multiply. That's it. That was the only logic for this particular problem, right? This was all of my encrypt values. Now let's discuss the last problem for this particular contest for this video basically, which is T-Perm. This T-Perm is also a good problem. So basically in this problem they are saying that you have to first of all represent your integers in ternary manner, not binary manner. I will tell you what ternary is. You have to represent your number in ternary manner, which is base 3, and a integer is considered as good if its ternary contains a digit 2. So what is the ternary representation of a number? We all know about the binary representation. For example, there's a number 23. If you want the binary representation of that number, what you can actually do is you can take 23 and you can keep it dividing by 2. So divided by 2, remainder is 1. Divide by 2, remainder 1. Divide by 2, remainder 1. Divide by 2, remainder 0. And finally 1. So your final value of this in binary will be 10111. This is the binary representation base 2. If you will do the same thing, you will divide by 3, it will be base 3. So divide by 3, remainder will come as 2. So remainder will come at 2, and here it's 7 will come. Again divide by 3, here remainder will come as 1. Okay, and value will be 2. Now divide by 3, remainder will come as 2. So here the value will come at 212. Right, so this is the ternary representation. So this is the binary representation of 23, which is 10111, that we got after dividing that by 2, and this is the ternary representation of a number, which is when we divide by 3, base 3. Okay, now a number is considered good if it has 2 in their binary representation, in their ternary representation. Binary में तो हो ही नहीं सकता है. If a number has 2 in their ternary representation, that means the number is good. Okay, for example 23 is good, but if you will see 22 is, I think, not good. Why? If you will divide by 3, remainder is 1, 7. Okay, 22 is also good actually. 20 is maybe not good. Yeah, so this will come as 1, not 1. Okay, this will also, okay, 21 maybe. This will come in remainder 0, 7. Then 3, remainder 1, 2. Again 2. So ये भी है. A simple ले लेते हैं कि let's say a number 2, a number 1 simple. So binary representation of let's say 4. Binary representation of 4 will be, ternary representation of 4 will be remainder 1, 1 and remainder 1. So ternary representation of 4 is 1, 1, means 1, 1 in ternary. So means 4 is not a good number, but 23 was a good number. Why? Because it contains 2 in its ternary representation. That is what the difference of a good number is, right? Now what they want is that you have to find a permutation of size n, means from 1 to n, you have to find a permutation such that the value of pi plus I, means a number plus its index, is good. A number plus its index is good. For example, the permutation that I've got is simple 1, 2, 3, 4. Let's say n is 5, and permutation that I got is 1, 2, 3, 4, 5. Indexing is 1 base, so indexing is also 1, 2, 3, 4, 5. If you will find the sum of a number and indexing, it is 2, 4, 6, 8, 10. Right. Up see guys very carefully one thing. Very carefully. If you will see, 2 is actually a good number. Why? Because 2 is a good number. Because the ternary representation of 2 will contain 2. Okay. But if you will see that, this 4 is not a good number. This 6 is actually a good number. it contains 2 as the remainder. So 6 is actually a good number. 8 is also a good number. 9 is actually, I guess, 10 actually is not a good number. So it will give 9, 3. 10 is not a good number. But you have to rearrange this permutation such that all are good numbers. Means all have 2 in their ternary representation. Ab see guys very carefully. For example, you have n5. Let's arrange them in a reverse order. Let's say 5, 4, 3, 2, 1. Okay. It would be 1, 2, 3, 4, 5. Okay. Up see. This is the array. If you will find their sum, it will be 6, 6, 6, 6, 6. Do you got something? When we rearrange a number in the reverse manner, every number, the sum that we get, means the number with its index, is always 6, 6, 6, 6, 6. Is always 6, 6, 6. Which is n plus 1. Means when we rearrange a permutation in reverse manner and we get the sum of every number which is index, the number that we get is n plus 1. So if n plus 1 is a good number, that means we can rearrange our permutation in a reverse manner. Exactly. And that will be absolutely right. But how to check whether a number is a good number or not? To check, it's very easy. Simply divide the number by 3 and check if there is any remainder to come or not. Very simple, brute force manner. So if you will see here, I have actually written a function. Here which is good function. This function is taking a number n as the input. It is taking the remainder of this number n every time. If remainder comes as 2, means the number is good, means it contains 2 in the ternary representation, return true. Simply return true. Else move on. And if for all the bits there is no 2 present, return false. So simply using this is good function, we can check that whether the number is good or not. If it contains 2 in their ternary representation or not. Right. Now see, as I told you, when we print reverse permutation, 1 to 9, 1 to n in a permutation, then the sum that we get is always 6. That means if n plus 1 is a good number, we can actually print a array in a reverse manner. Actually, this is not, but let's say if n is 7, and if you print 7 in a reverse manner, this is the array, and the indexing will be 1, 2, 3, 4, 5, 6, 7. Then you will get the sum will be 8, 8, 8, 8, 8, 8, 8. And you can see that 8 is actually a good number. Because if you divide it by 3, you get 2 as a remainder. So means if n plus 1 is a good number. So I am checking if is good n plus 1. Then simply print the whole array in the reverse manner. From n to 1. n minus 1, n minus 2 up to 1. Okay? That's the first thing. Up next thing comes if n is good. मान लो n good है. For example, n is 8, which is good. N is 5, which is good. Then what we do? In that case, what we will do? We will print like this. So we will not print n here. We will start from n minus 1. We will say 7, 6, 5, 4, 3, 2, 1, and then we will print 8. Because if you will see here, if I will actually doing it like this, you will see that the sum that we are getting is 8, 8, 8, 8, 8, 8, and 16. Basically, the sum we will get will be n, and 2n. And because we have already checked that n is a good number, we can have the sum as n. And because n is a good number, and that means 2n will also be a good number. That's a obvious thing. Because when we multiply it by 2, वो तो difference रहेगा ही ना. 16 will also be a good number. Okay. Any multiplication of 8 will be also a good number. You can see 16, 3, 1, 5, 2. So that will also be a good number, right? So if you will see here, what I did here is basically that I know that n is a good number. So because n is a good number, I will try to make the sum of my permutation as n. What I did, I started from n minus 1, 7, 6, 5, 2, 1. So that after adding this n minus 1 with 1, it became 8 only. You can see when I am checking that, okay, if n plus 1 is a good number, then simply print from n to 1. If n is a good number, then print from n minus 1 to 1, and then at the last extra n, this 8. Else, see guys, agar, remember, if n plus 1 is also not a good number, if n is also not a good number, that means n minus 1 is definitely a good number. Because in after every two numbers, there will be a good number. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. If you will see, this is not a good number, this is a good number, this is not, this is not, this is a good number, this is not, this is not, this is a good number, no, no, yes. So if you will see, every second number is a good number. Why? Because if you will divide every number by 3, every second number will give remainder 2. This will give remainder 2, this will give remainder 2, this will give remainder 2. Every third number, sorry, not every second number, every third number is actually a good number, because it will definitely have a remainder 2. It will definitely have a remainder 2. And that is what I am doing here also. If n plus 1 is not a good number, if n is not a good number, that means n minus 1 is definitely a good number. Simply print in such a way that you get a sum as n minus 1. So what I actually did is, for example, if n is, let's say, 9. So if you say n is 9, you can say that n minus 1, which is 8, is a good number. What I will do, I will actually start from n minus 2. So I will start from 7, 6, 5, 4, 3, 2, 1, and remaining then I will print 9 and 8. So if you will take the indexing here, so the sum that you will get will be 8, 8, 8, 8, 8, 8, 8, 16 and yeah, 17 and 17. And you will see that this 17 will also be a good number. You can see. This was a simple observation. This is a simple observation that you can make, right? So guys, this is actually a solution of this problem. What I have solved it. Okay. So cool guys. I hope that you have got the complete understanding of these 6 problems, right? If you have any doubt, you can ask that to me in the comment section, or you can also join our Telegram, right, to ask your doubt. And I hope I have also explained in a good way, just like Abhinav explains. Okay. So please comment if my explanation was good. Thank you for watching this particular video. See you in the next video. Thank you.